Hi, I'm John Thompson, and I'll be presenting with Jesse Martinez. ChartReader is an accessibility engine that renders visualizations for screen reader users. We designed these accessible experiences through a co-design study with 10 people who identify as blind or low vision. You might have used a COVID-19 chart similar to this one over the past few years. Perhaps you use it to decide whether or not to attend a conference in person. If you were cited, what did you notice when looking at this chart? Maybe your eyes saw a big upward trend and you were more cautious. Or maybe you saw a downward turn, a reason for optimism. Visualizations are largely not inclusive to people who are blind or low vision. Despite screen readers being a core assistive technology for people, there is limited support for visualizations, posing an equity problem for information access. A screen reader announces text and/or other page elements, such as coronavirus in the US, latest map, and case count. But when it comes to this chart, the screen reader might altogether skip over it. Or even more confusing, it announces garbled version of the SIGCHI text here. Recently, there has been an increased focus to enable blind or low vision individuals through data modalities that improve accessibility. Previous research and tools have explored improved textual description, access to individual data points, reusing the chart elements as structure, and sonifying data as audio tones. Most only support one or two modalities. We present ChartReader, a web-based accessibility engine that renders accessible visualizations. Our approach extends previous work in accessible visualization by mixing all modalities. ChartReader requires a tabular dataset, a chart configuration, and a data insight list to render a chart like this. Focusing on the chart will announce a description and summary insight. Here's a snippet.
Summary insight. The chart contains 3 distinct peaks where average cases otherwise remain consistently low.
Text alternatives describe complex trends or descriptive statistics. Instead of one summary, there are many type summaries.
Data insights. There are 11 total data insights, 1 summary, 5 trends, 4 landmarks, 1 statistics. Grouping. Summary data insights. 1 total. Trends data insights. 5 total. Grouping. Landmarks data insights. 4 total. Trends data insights. Second largest peak, winter 2021. Average cases go from 7 to first increase of cases, winter 2021. Cases fall, spring 2021. Highest reported cases, winter 2022. January 14, 2022 sees the highest number of reported cases, with 806,795.
Access to underlying data points supports autonomy to explore the data.
Grouping. 71,786 cases, November 7. Graph, 74,097, 75, 76,800, 83,000, 91,000, 92,000, 83,000, 100, 119,609 cases, December 10.
Yet, as you can imagine, it's cumbersome to compare so many numbers and keep them all in your head. Instead, sonification maps data to synthesized audio tones.
805,062 cases, January 15. Graphic. 378,951 cases, December 31st.
People can perceive change in pitch, especially for temporal trends like this. Finally, organizing the interaction based on chart elements provide varied ways to access the data. Here, the x-axis is bin by month.
January 2020 average cases is 1 of 28 bins. April 2022 average cases is 38,667. 28 of 28 bins. March 2022 average cases is 35,344. 27 of 28 bins. February 2022 average cases is 178,003. March, April 2020. March, Feb, Jan, no, August, August, July, June 2020.
So our work strives towards a cohesive experience of multiple distinct modalities that can also be flexible and customized to users' contextual preferences. We also wanted it to fit into how they currently interact using their screen reader or other assistive tech, and specifically that our tool didn't require any specialty tools, specific screen readers, or particular extension, plugin, or hardware to be usable for a user. To accomplish this, we conducted a participatory design study with 10 blind and low vision design partners who used screen readers conducted over a period of 5 months. As is often the case with this type of study, our design partners were the fuel and driving force behind this project, pushing our design far beyond what we initially could have conceived. In addition to being experts in their own disability and providing rich insights in that domain, our design partners also had a fantastic range of other perspectives they brought to the study, including how the assistive tech they used, from distinct screen readers to magnifiers to braille displays, would affect their experience, a range of familiarity with charts, from novices who had never interacted with a chart to expert data scientists, varying levels of familiarity and expertise with screen readers, from novices to a former screen reader developer, and distinct disability personas, including congenitally blind partners, partners with degenerative blindness who had previously visually interacted with charts, and a low vision partner who continued to visually interact with charts using a high contrast magnified display. Our study also utilized a structure uncommon to participatory design studies, in which we began each of our 3 rounds of the study by presenting each partner independently with the latest prototype for soliciting feedback, and then analyzed and synthesized all partners' feedback before revising our prototype for the next round of the study. Briefly describe each of the 3 rounds of co-design, our first session with each participant focused on understanding the initial learnability of our tool, applied with our simplest chart form, the single series line chart. Additionally, as this was the first time our multimodal design was being tested, we particularly sought out insights on where cracks emerged between the different modalities and how we might create a more fluid, cohesive experience across them. Our second session added more complexity in the charts through the inclusion of multi-series line charts, which pointed to a particular focus on how to navigate the complex structure of the data in our charts. We also focused in this session on how we could integrate our design into users' existing screen reader practices, which proved critical for enabling our partners to have context for the data as they explored these more complex charts. And then finally, our third session explored new ways to interact with and explore the data, specifically in how to compare data and trends in the visualizations, and how to custom filter and select what data each partner wanted to engage with. This session also introduced stacked bar charts alongside our previous line charts, which was a useful new domain where we could further explore the needs around data comparison.
We iterated on modalities and their intersections with our design partners. At times, multiple refinements were needed. In the end, we learned lessons that can be generalized to accessible visualization experiences. We learned that sonification and descriptions are interoperable representations of data.
Are 70. Great Britain
Here,
total medal. Japan total medals are
navigation
58.
nouns the chart
5 of 5
element.
countries. 27 medals. Japan. 22 medals. 20 medals. Russia. 38 medals. 39 medals. United States. Gold series.
The shift key modifies navigation by sonifying what's focus. Pausing announces again.
27 medals. Japan. Gold series. 22 medals. 20 medals. 38 medals. 39 medals. United States. Gold series.
Signposts and orientation features are needed to wayfind in the chart hierarchical tree structure. Which number
Y-axis
total
displaying
and
medal
element
count
type is
from 0
announced
to
for
120.
orientation.
This component displays stacked bars binned by increments of 0 to 30 medals bin contains 3 stacked bars. Gold for 30 to 60 medals bin contain 60 to 90 medals bin contains 5 stacked bar. 90 to 120 medals bin contains 1 stacked bars.
Also, physical barriers are provided as ear cons, such as this bonk nose, to let you know you're at the end of the list. With our design partners, we learned helpful and unhelpful accessible design patterns. The lessons that we learned, such as orthogonal varied access to data supports users' preferences, insights, not annotations, describe a picture with your words, but be consistent in how you describe them, reading versus announcements, enable reading in document mode, don't just announce long textual descriptions, enable comparisons of data, such as using spatial audio for multi-series line charts, and then provide random access to data, such as filtering, which enables people to focus with large datasets. For more information about our project, please see our paper or reach out to us directly.